Good day everyone. My name is Eunice with metric number 293900. In this video, I will present and explain about my pseudocode for the case study, TNB electric bill calculation system. Pseudocode is a tool used in problem solving to design algorithmic solutions before actual programming begins. It uses natural language to describe and explain the logical flow of a program without focusing on the programming syntax. Pseudocode is designed to be simple and easy to understand for effective problem solving. It serves as a blueprint for converting logic into executable program. There are several key principles that I aim to achieve when writing the pseudocode. The first principle is to use general terms and natural language for easy understanding. The second principle is to maintain a standard structure with consistent syntax and indentation. The third principle is to avoid any unnecessary details unless they are important for the logic. I will explain the format and structure I use to write the pseudocode. The pseudocode follows the input, process, output structure. I label the algorithms with a short title that explains its purpose. The input is the data collected to be used in the process. The process contains the main logic and operation, including calculations or decision-making using the input data. The output is the result calculated and returned by the process. Next, I will explain about the syntax I use to write the pseudocode. All pseudocode keywords are written in uppercase to differentiate between the syntax and the variable. The pseudocode begins with start and ends with end to indicate the overall beginning and conclusion. Data type declaration and variable initiation are optional in pseudocode because it is not necessary in some dynamic programming languages. The set keyword is used to assign values to variable. For calculations involving formula, I use the syntax calculate variable as formula to clearly show the operation. The conclusion for decision and loop structures are clearly marked with their corresponding ending keywords. For example, endif and endfor. This is to make the pseudocode easy to follow, especially in nested condition. The print keyword is used for the output operation because it is similar to the output in common programming languages. Now, I will explain the logic of my algorithm using pseudocode, following the structure of input, process, output. The pseudocode begins with a start. First, I will print the title of the system. The first algorithm declares the constant variables where its value will not be changed throughout the process. Block tariff and kadar tariff are declared as arrays and their values are assigned based on the table in the case study. Algorithm 2 calculates and fills in the values in the berata block and jumlah block arrays. Kadar penggunaan is obtained from the user input. Next, paki penggunaan takes the value of the kadar penggunaan. This avoids confusion because paki penggunaan is used in the calculation process and its value changes during the iteration process, while kadar penggunaan remains the original value and will be used as input in the following algorithms. I is used for the iterative process to check the baki penggunaan. The process repeats until all blocks are processed or baki penggunaan becomes zero. Block tariff and kadar tariff are read and used in the decision-making process. Baki penggunaan and block tariff are used to calculate and fill in the berata block arrays. Berata block and kadar tariff are used to calculate and fill in the jumlah block array. The output berata block and jumlah block are the results of the iterative calculation process. Based on the decision control, 3 cases will happen. Case 1, if baki penggunaan exceeds the current block tariff, the berata block will take the value of the current block tariff and baki penggunaan will be subtracted for the next iteration. Case 2, if baki penggunaan is less than or equals to the current block tariff, the prata block will take the value of the baki penggunaan. Case 3, when I equals to 4, means that we have reached the last iteration. Since the last block tariff can accommodate any remaining usage above 900 kilowatts per hour, therefore, the current prata block will equals to the baki penggunaan, similar to case 2. Algorithm 3 outputs 5 rows of data from the arrays. I is used for the iterative process and decision control. Block tariff, prata block, kadar tariff, and jumlah block arrays all contain values. The values at the same index in all of the arrays are read and print in the iteration process. When I equals to 4, the value of block tariff 4 is replaced with the text more than 900 by using a decision control. Algorithm 4 calculates the total usage. Jumlah block is used in the process to calculate jumlah penggunaan. I is used for the iteration process. The iterative process sums up all the values in the jumlah block array to calculate jumlah penggunaan. The output jumlah penggunaan is the result of the calculation process. Algorithm 5 calculates the SST. I is used for the iteration process. SST is applied to kadar penggunaan above 600 kilowatt per hour, which starts from block tariff 3. Therefore, the initial statement is I equals to 3. Prata block is used in the formula to calculate penggunaan cukai SST. Jumlah block is used in the formula to calculate jumlah cukai SST. Penggunaan cukai SST and jumlah cukai SST are calculated by summing up the last two values in the prata block and jumlah block arrays. The outputs penggunaan cukai SST and jumlah cukai SST are the results of the calculation process. Algorithm 6 calculates KWTBB. Kadar penggunaan is read to check if KWTBB applies. KWTBB is applied if kadar penggunaan exceeds 300 kilowatt per hour. Jumlah penggunaan is used in the formula to calculate jumlah KWTBB. The output jumlah KWTBB is the result of the calculation process. The last algorithm calculates the final payment. Jumlah penggunaan, jumlah cukai SST, jumlah KWTBB are used in the formula to calculate jumlah pembayaran. The output jumlah pembayaran is the result of the calculation process. Lastly, I have uploaded my pseudocode to a GitHub Markdown file. Instead of displaying my pseudocode as a plain text, I wanted to include syntax highlighting to make it more readable. I found out that Python has the most suitable syntax highlighting. It effectively highlights all the pseudocode keywords and display the variables in black. That's it for my presentation. Thank you for watching.